Hey, what's up, Franklin West? So I have the part two for the solving linear equations at the proficient level coming up for you. I decided that the videos risked being too long as a new YouTube member with the channel. I have very strict limits on how long my videos can be. So here is the second part, and then there will be a third. Enjoy the video.
And we're back. If you saw the first video, we had just spent time solving this equation with variables on both sides and doing a check to prove our work. We're now going to slide over to this one. This problem also has variables on both sides, and it has a grouping of parentheses here. And what I love about this problem is there's just this subtraction sign, or you might call it a negative sign, and it's out here all alone just outside that parenthesis. So we're going to talk today about how you handle this problem. We'll work in purple. So this right here, the moment you have a grouping of terms, whatever is just immediately outside of that is needing to be distributed into every term in that parenthesis grouping. So it's not anything to do with the 14. This 14 is kind of out on its own island. We're not even going to need to deal with it. And so because we won't deal with it till step 2, I'm just going to bring it down unchanged so we can kind of forget about it a little bit. And I could say, I know that we're going to equal 3x on the other side. That too will wait until the second step. So when we go to do this distribution, that whatever is outside the parenthesis will go to each term. Now, I've seen students even up to just a few days ago where they write these arrows, these arcs, but then they don't actually complete the full distribution. So make sure you're watching and listening carefully here. It's not enough to just draw these arcs to get the right outcome. So this is multiplication. And what number is hiding here? Well, there's a 1 hiding there. I say this with absolute love, but mathematicians are super lazy. They're not going to write every sign like they don't for positive numbers. We don't write a positive symbol in front of it. We get to assume it's positive. And every time we have an x all alone, we get to assume that that's 1x and that it's to the first power. We never have to write all those notations. And so the same thing here. That's actually a negative 1 hiding in here. And so you're going to multiply a negative 1 to each term. Now, let's say you didn't see it was a negative 1, but you just saw the negative. Another way you could think about it is anytime you see a negative outside of a grouping, it's really communicating opposite. Create the opposite of what is inside. And so right now we have a positive 3x and a positive 2. So what are the opposites of those two terms? Well, the opposite of 3x is negative 3x, and the opposite of 2 is negative 2. And that's because in the math world, the definition of opposites is they add to 0. So either way you think about it, as long as you're thinking about it along those terms, then you're going to be okay. So a negative 1 times a 3x will get me a negative 3x. And then again, the second arrow, don't forget it, a negative 1 times a positive 2 should get me a negative 2. So there, we've expanded. So now we have a bit more going on, but that's okay. Now as you scan, there's still only one term on the right-hand side. Not much we can do to improve there. So let's take a look at the left-hand side. We have 1, 2, 3 terms. Now we got to look for common terms, or sorry, I should say like terms. We're going to combine any terms that are like. 14 is just a number. And this 2, and don't forget, that's a negative 2. That's just a number, whereas this negative 3x is the only term with the x variable. So the only two that are alike are 14 and negative 2. And so as we consolidate them into one number, 14 minus 2 is 12. We did nothing with that negative 3x, so it's just going to come down along with this positive 3x on the other side. And for those of you that hate to show your steps, I totally get it. And yet this is the way you're going to strengthen your learning. So you really should do this rather than having pockets of things that consolidated here or there and then try to pull it all together. This really outlines the steps in your thinking. So now these are not like terms. They cannot combine. But I do see that we have like terms on opposite sides of the equation. So this is where we're going to continue to do our inverses. We're undoing. So if here's a subtract 3x, well, I need to undo that by adding 3x. And I'm going to do that to both sides per the rules of algebra. This leaves me with a 12 all alone. Remember, all this made a 0, so that's gone. And then 3 plus 3 is 6, so I have a 6x. Another thing I see students do is they'll forget their variable along the way. So try not to do that. Never lose track of your variable or your negative signs. That's a common thing to do too. Okay, so we may have seen this in the last problem if you watched the prior video, but this is a number but up right next to a letter. So that 6 in the math terms is a coefficient. It's any number that's ahead of a variable. That's what a coefficient is. And then this x, your alphabet letter here, is your variable. And so we're trying to find the value of x if 6 times a number is 12. And so I kind of jumped the gun a little bit there, this times thing. Anytime you see a number right up next to that variable, a coefficient next to that variable, it's multiplication. And so how do I undo multiplication? You guessed it. We have to divide. Again, dividing by to both sides. So 12 divided by 6 is 2, and that equals x. Now, if you hate looking at it this way, because maybe you've kind of been trained or are used to x equals first, you could rewrite it, and you could have that be x equals 2. Whoop. But there's nothing wrong with 2 equals x. It means exactly the same thing. So, as you guessed it, we should do a quick check. Let's see if I can do this in record time. We'll work in green. So, here's our check over here. We need to be able to say, okay, if we say that x is 2, we need to prove that when x is 2, this whole left side equals the right side. And so if I have the original equation, 14 minus 3, and look at what happens, because I had said before, anytime you substitute in a value for a variable, use parentheses. Now we have parentheses inside parentheses. Totally normal. We'll talk that through if that alarms you at all. And then there we go. Even on the other side of the equation, we plug in our value in for the variable. So when we're working with nested parentheses are parentheses within other parentheses, kind of like those Russian nesting dolls. We always work on the inside first. And so the innermost parentheses are, if we can do that work, that's where we should begin. So because we can do 3 times 2, there's nothing stopping us there. We can recognize that that is a 6. So this inner parenthesis is 6 plus 2. I'm just building what we have not touched yet on the other side. And we might as well clean this up because there's no rule saying this has to come down unchanged. We can recognize that that is a 6 also. So again, we could do this inside parentheses first. 6 plus 2 is 8. So we have 14 minus 8 equals 6. And if you know what 14 minus 8 is, you will recognize that we have the correct solution. The left side does in fact equal the right when x is made to equal 2. And there we go. That is our next one. And again, because I don't want the videos to be too long, I'll show this one to you as a preview, and I'll make another video just focusing on that one.
So I hope that video was helpful in helping you understand that content. If you are interested in knowing more about this or another topic, do not hesitate to reach out to me. You can always email. If you have YouTube permissions from your parents, you can comment below and tell me what topics you would like to have added into my video list to help you with your continued math learning. And don't forget, if there is science stuff that you need some help with, I can work on providing materials for that also. So I hope it was helpful. Good luck in all that you do. You're all wonderful people.